This is IBM Museum. In this video, I'm not going to have any system powered up, but I'm wanting to go over the different types of planars that were in the PS2 Model 80. And I do have all of them in the humongous anti-static bags here. And we're going to set this particular one off to the side. I'll get back to it at a later point. This is what I intend to put on the system and actually upgrade the CPU. And the main function of this video is to kind of show the CPU and other placement on these planars, so I can show how some of the later Model 80s were rather a little bit more of a challenge to do anything like a CPU upgrade, or where that CPU upgrade is. I'll have a later video to this just showing how to get into the system, into that area where the CPU is, to look at the upgrades I have inside. So let's start pulling these out of the anti-static bags and showing them off. And first up is a Type 1 planar, and that means a 386DX 16 megahertz in this case. And this is a very similar orientation to how I had the Model 80 test bench when we went through and had the adapters plugged in that this ultimately is towards the top of the case. This is the PSU connection, or power supply connection, the floppy drive connector, the memory connectors here for the memory modules. Here is the BIOS of the system and 4 EEPROM chips. And we have the slots going from slot 1 up to slot 8. This, of course, being the bottom of the case, this being the rear of the case. We have the breakout connections from the planar, in this case the VGA, serial and parallel ports, and keyboard and mouse ports. Here's the speaker and battery connection here, a little 6-pin header that goes into there. And in this case, I've populated all the planars with a CPU and the floating point unit as well. So this is a 386DX 16 megahertz, and then there is a 387DX coprocessor on this unit, just to show the location and the orientation. Of course, you may encounter a lot of the Model 80s that didn't have the floating point socket with a chip in it to add that functionality. Now, in this case, the Type 1 is notable against the later Type 2 and Type 3 planars, in that the CPU and floating point unit are down here in front of the adapter slots. You'd have the adapters in here. Any full-length adapter, normally these aren't enough height to interfere with any adapters that's in the slot, but that was a concern for IBM, and they went through as you'll see on the Type 2 and Type 3 planar, they moved the locations of the CPU and floating point chip up higher on the planar to be assumably out of the way of these adapter positions, and also to provide a little bit more cooling, to be right under the fan of the power supply, to where that air is pulled in over the top of them. And there was some direction of the air as IBM had set up. They had a kind of a vent assembly on the cover panel that we'll see when we look at the system later on, to how the airflow was directed over the adapters. But apparently they didn't determine, even for the relatively low heat that the 386DX generates, comparably and never really required a heat sink, to thinking that that area needed to be cooler, or to be cooled a little bit better over the CPU and FPU. So let's look at the Type 2 next. Okay, and this is the Type 2, and this actually I think is the planar that I used on the test bench with the adapters. And I don't know if the close-up enough view on that video was to show all these bodge wires and things like that are on there. This is sometimes typical on some of the planars and adapters for IBM to kind of add these engineering changes, or figure out when they created the PCB board that they may have not had some interconnections or functions just exactly right, that they need to go through and later on and add a few extra wires in the layout for the how they're making the planars at that time. Now with the Type 2, we of course have the internal connections are at the same places. Power supply, floppy drive, memory adapters. I mean, this goes in the same case. So all those connections off the planar are in the same positions. And the adapter slots here, we didn't go over in too much detail, maybe in that video to talk about the 16-bit slots and then the 32-bit slots with the matched memory extension, and then the 16-bit slot here being with the AVE connection, the auxiliary video connection. And in normal instances, that would just be one of those auxiliary video connections when there was video on the planar, this being the VGA chip, and here's the RAM DAC. This is the VGA connection out of this planar. But there were cards, primarily the 8514/A, that could be in this slot for some of the tasks with that vector graphic standard. And then it communicated through the auxiliary video extension with the VGA chip that was on the system planar to get the basic functions, basically, that it didn't support itself. Now, again, as I referred to on the Type 1, you can see that they've now moved up the CPU and FPU, whether that's a socket or populated on a chip, to this higher position to be a little bit closer to where the power supply fan is underneath, and assumably be cooled a little bit better in these positions. And this is going to be a really big impact that we'll look at with the completed Model 80 to see where these locations of these chips end up being. And for the Type 2, IBM went through and they've reduced those 4 BIOS EEPROMs to 2. So basically a single chip is covering the instance of 2 chips for the Type 1. And now we're going to go through and let's look at the differences to a Type 3. And the Type 2, before I forget, is a 386DX 20 megahertz. So it's a 4 megahertz faster than the Type 1. And this is the Type 3 planar. There is some enhancements in some areas where they actually have clips for the memory modules, I guess, to clip those in place a little bit better. I don't know, since those memory modules are tucked so deeply down inside, you'd almost require a tool to basically slip in there to release these clips when this planar is in a completed system. And we'll see a little bit of that when I do go over those full-sized or complete systems that have all the components in the positions that they should be. You'll see how tight some of these spots are for like the memory modules. And we do have the connections external to the planar, of course, are in the same position again. And We still have the EEPROM for the BIOS in 2 chips, just like the Type 2 was. Speaker connection, battery connection right there. And for the slots, IBM went through, and there's been a little bit of pondering lately on this feature to where it has 2 of these slots with the AVE extension, the auxiliary video extension. And the AVE being designed for one adapter basically to use that connection at a time. It's pondered why there's 2 slots to support those 8514/A adapters. And I'll probably even go through and on some video just to kind of show those adapters. I do have some ones that were new in box that I have. I just have to determine if I'm going to go through and open those up and show them at this period of time or a little bit later on. So the Type 3 is a 386DX 25 megahertz, and it actually went through and added 64 KB of cache. These are the cache chips, and cache controller. This is an 8385 cache controller chip. Not to be confused with the 8386 CPU chip. They're just differing by number, but they're associated chips. This is designed purely for cache control presented to the CPU. And the floating point unit is off over here. We start to see some of the markings that Intel used later on, a little bit different from the CPUs that are on those earlier Type 1 and Type 2 Planars, and just kind of that black lettering. They get a little bit more extensive here with the music bar and the white lettering on those chips. But you can see that the CPU and floating point unit chip are still up towards the top of this planar position to be close to that power supply fan, and assumably to get better cooling from that fan as air is pulled through the PSU. And back to the Type 1 planar that I want to go through and put in as a complete system, put it into a case. All my completed Model 80s right now are either the Type 2 or Type 3 planars. And I wanted to have a Type 1 as a fully built model as well. And was looking at kind of the CPU upgrades that I can have for all the Model 80s that I have, because the Type 2 Model 80 and the Type 3 Model 80 that I have both have CPU upgrades in them. So I thought for the Type 1, I'd also look at replacing that 386DX 16 megahertz on the planar in the system, just to enhance performance. And I had it selected and went through and actually made an announcement that I was looking at putting in this Cyrix CPU that's clock doubling and goes through and makes it basically supports a 486 instruction set. And this is the CX486DRX2, and this would basically run internally at twice the clock speed of the external planar. So it would normally run this chip internally at 32 megahertz for that enhanced performance, just like a 46, and without the coprocessor inside. I did have a Cyrix FastMath chip here that I also was looking at. It would be clock doubled internally, but would just these chips are optimized to work a little bit more with each other rather than the standard Intel 387 DX chip. There's just some modified registers and things like that they work a little bit better together than having the comparable Intel coprocessor there or some other manufacturer coprocessor coupled with this Cyrix chip. Now, I kind of changed my mind a little bit with this as well once I got looking at an upgrade, and this is a 46 now Kingston CPU card that was sent to me by Charles Lassiter, and he included this with a Mul 70 that he sent me, and just as kind of a bonus feature. And I just got looking at it, and the thing I found interesting was that for all the Type 2 and Type 3 planar, when they move the CPU, there's particular orientations of the sockets. In Kingston in particular, they made upgrade modules for the lower end PS2s that upgrade the 286 chip, and they had to make it in different styles for the different systems, because those systems would have the CPU in different locations on the planar, different orientations, different adjoining connections or chips that would be close that they had to account for. So they would create basically different versions of the CPU upgrade boards that they did. And I looked at this and I started comparing it to some of the things on the Mul 70 units as well as the other Mul 80 units. And the interesting thing was when I looked at the orientation of this on the Type 1, it would go in basically in this position. And I'd have to go through, and since it does have the floating point unit on the CPU in this case that goes in, as this goes in the socket, you don't have this floating point unit socket populated anymore. You pull the chip out of there, and of course the CPU is removed, so you can put this assembly in there. And that's why I kind of noticed is the speaker connection, when this would be in the socket, has this little notch that seemingly to avoid that speaker connection. So this is going to be the upgrade CPU board that I'm gonna put in this unit when I have it in the case, and we'll see that unit in a later video as I put that together and get it configured and what else I go through there and add to that unit. So going through and using the extractor, one of the extractors I have for removing the CPU and floating point unit, I did pull those Cyrix chips that I determined I'll probably put those on a Mul 70 and have that on video at a later point. But I do have that CPU upgrade board in place. It doesn't quite necessarily, that notch doesn't match up to where the speaker connection is, but it just looked like that that CPU upgrade was still designed for a Type 1 Mul 80 a little bit more than the other 386 DX based systems that I tried it on. And of course I was just trying it on the IBM systems. An interesting aside for the 386 DX CPU is that IBM never had that CPU version in an ISA mode. All their 386 DX were in a microchannel form on the systems. And IBM did have PS2s with the 386 SX for the ISA bus, but did not use any 380DX in their systems except for microchannel. So that's all I have for this video. I'm going to include some links to the pictures I do have the planar and include a little bit more details that I may have not gone over on video, as well as some of my upgrade plans, and those will be covered on later videos that I'll do once this particular planar is in a case. I'll demonstrate that and just show the Type 2 and Type 3 planars that I have in the case with their upgrade CPUs and where those are in the system. But that is all I have for now. Please like this video if you enjoyed it, and please subscribe to my channel. This is IBM Museum. Thank you.